All right, hello everybody. Welcome back. Wednesday, 10:21. Thanks for giving me Monday off. I spent the day becoming a licensed septic installer. So, yeah, interesting process. They talked a lot about fluid mechanics, which I know you don't have right now. This is engineering problem solving, but it was really great. Lots of blue-collar folks in there, so to mix an engineering with them was, I think, good experience for most of them. So anyway, it was a lot of fun. But we need to get back to it. We have an exam coming up fairly soon, so I want to get through the graphics part before we have the exam, so then we can move on to some other stuff like Excel and a little bit of AutoCAD and a little bit of SolidWorks maybe and some other fun stuff. So that's going to be a little problematic because you all don't have the software, but we'll figure it out. But today I want to talk about scale. We're going to do some more hand sketching. So one of you did ask me about hand sketching. Several of you, I think, have actually expressed some, enjoyment of doing it. But the question was how relevant or how consistent is hand sketching out there in industry? And the fact is, you won't do a lot of it, but you will do some of it. So a lot of times we mark up. So we'll have a drawing in front of us and we do some markings on it. And somebody's got to either read that markings or you have to read that marking later and put it into CAD. So your ability to make a quick sketch is going to be pretty important. It depends on the company and the position you take also. I can envision positions that would never do it, right? But those positions, you will be reading drawings. And the way to learn to read a drawing is to make a drawing. So if you start straight into software like AutoCAD, then you will end up learning the software instead of like learning how to lay out a 3-view projection, right? Or how to do appropriate dimensioning. So I think it's really important that I slow it down like I've done, and we just focused on orthographic projection. We focus on our ability to see hidden lines and hidden geometry. And then we will start into dimensioning, and we won't do tons of it, but I'll make sure you have the basic rules down for dimensioning so you don't just throw them on everywhere. But today we're going to work with scale. So we're going to practice with our little triangle scales. Everyone should have them by now. I'm going to use the engineering scales for example, but the architect scale works very similar. So today in your exercises, you'll be given the size of the object by me telling you that, it's 5 inches between the ticks, or it's 10 inches between the ticks, or that gives you the size, and we'll talk about that a little bit. But then you have to figure out how to get it onto a piece of paper, right? Which means you have to scale it or bring it down in size. But we still want the correct dimensions, and we want the correct geometry. So let's look at how scale works. I'm going to flip you to the paper. All right, so the way scale works is in the engineer scale, we should be able to find a 10 scale. See how it says 10? That one says 30. That one says 50. 10 scale. So the 10 scale means that every inch is broke up into 10 increments. And that means that is what? That is 1/10 of an inch, or 0.1. So if the number is, let's just say 2.34 inches, that's accurate to the hundredths. And if I want to draw it 1 to 1, 1 to 1 is often, that's often the symbol, and that means 1 inch equals 1 inch. So 1 inch in real life equals 1 inch on the paper. It's a 1-to-1 or a full scale. Okay? And then to get full scale, I use the 10 scale, and I literally come from here, and I go to the 2.3, so 1, 2, 3, then I got to guess at 4. So here is the 3 mark, 1, 2, 3, and then here's the half, I'll go a little less, boom. That is my 2.34 inches, 1-to-1 full scale. Okay? So now, if I go and I decide, well, instead of 10 inches per inch, I can find a 20 inches per inch. And you have to flip it over to do that. And boom, there it is. So that means for every inch, there are 20 tick marks per inch. So what it does is it reduces the scale, right? And I'm going to read it here, 1, 2, right? So I know that I need 2.34, so 1, 2, 1, 2, 3, and 4 is right there. So right to there. See how it's exactly half? Because now we have 20 inches. So I'm going to actually flip it over so I can use it like this. I'll start in the same spot. And I'll go 1, 2.3, 4, boom, right there. All right, so that is also, and this is the important part, 2.34 inches. So we always want to write down when we're dimensioning, and again, not to mention yet, but I just want you to be thinking about this. We always want to write down the real size of the object. But notice that it's half as big as this one, right? That's how we get big things onto paper. And we would note in the title block, 1 inch, that's 1 real world inch, is 0.5 inches. I'm sorry. I'm thinking ahead here. 1 inch is 2 inches. So on the paper, 1 inch is 2 inches, right? 1 inch is 2 inches. So if I take a scale and measure 1 inch, it's like there to there. Where 1 inch up here was right here. I'm just showing you how this works. And it's right here, right? All right. So that is called a half scale. You can always think of it as fractions too. Like this is 1/1. This is half scale, 1 to 2 inches, right? Now, I did just write 1 to 0.5, and that actually would be making something bigger, right? 1 inch on the paper is 0.5, or 1 inch in real life is 0.5 on the paper. That would be blowing it up. All right, so let's jump to a really big scale. Notice that this thing has 30, has 40, has 50, and has 60. So I'm going to do a 60 scale, which means there's 60 little tick marks per inch, right? But I still read the scale directly. 2.34, 2. Oh my God, it's really tiny right in there, right? And that is 2.34 inches. They're all 2.34 inches. But this is a 1 to 6 scale. That is the biggest reduction that this can do. It cannot do more than 1 to 6. It's just, there's not enough room on the scale. And it gets too small. And that is a 1/6 scale, right? All right. So you maybe heard of quarter scale, 1/4, that would be the 40 right there. Quarter scale models, they're very common. All right. So let's just do the half just to show you how that would work. If we wanted to blow something up bigger, we would say 1 inch equals 0.5 inches. Now, that's not on here, right? It doesn't exist. So what we do is we take any number. So this is how you do a scale if you don't have one of these, is you just use your calculator. So for example, If I wanted a half scale of 2.34, I would divide by 2 to get the half size, and then I could measure that with the 10 scale at 1.17. 1.17. Okay? So it gives you, what it does is it gives you the real length measurement of some scale, right? So a 1 to 6, if I had 2.34 inches, I would take, sorry, you can't see that very well. I would take that 234 and divide by 6. And that gives me 39. I used to be able to find the angle for you. There you go. Maybe that's 0.39, right? So that means that real size is 0.39. So you can use your calculator. You can use your calculator to figure this stuff out. Now, to get a 1 to 0.5, I literally take the 1 and divide by 0.5. I keep that same system going, and you'll see that I draw it at 2 inches. Okay? So that means whenever you use your calculator, it's going to give you the real number on the 10 scale. So then I draw it at 2 inches, and I say it's how long? Oh, sorry. That's incorrect because I did the wrong number. 2.34, enter 0.5, divide 4.68. All right. That was probably a little more confusing than it needed to be. So 4.68 is right in there. So it's that one. And this again would get noted, 2.34 inches, right? 1 to a half scale. And that's also known as 2 to 1, right? So every 2 or 2 over 1 or 2 over 1, it's just a multiplier. All right. Well, that's a little bit about scale. I made a couple mistakes in there, so you might have to go back through and kind of rewind and rethink about it. Now, let's talk about your exercises. So you're going to go back to this page 160 in the 7th edition. That's this one, right, over here. And we're going to do some more of these puzzles where we have to figure out front, top, and side. Again, you're still sketching. Your last group of sketches looked really good. You had good projection. Some of you missed some hidden lines, but that's to be expected when you're first doing these. So there's lots here to practice. If you want to just practice and do extras, you can. But you don't have to. I get that. But let's talk about these. And we're going to put some scale to it. So these are going to be big objects that you have to get down onto a piece of paper, right? So you have to figure out not only how much to shrink it to get one view on, but you want to get all 3 views, front, top, and side, on this piece of paper. So you're going to have to lay that out with big boxes before you start sketching to make sure it fits, okay? All right, so let's look at the exercises. All right, so I'm going to have you do number 11 and 15. And I want you to do the front, the top, and the side. Front, top, side of these 2 drawings. And then I'll have you look on Blackboard to see what scale you're going to use. In other words, I might say each full tick mark is 5 inches. So that means from here to here is 5 inches. I'm going to zoom in a little bit. See if I can get a better... Oh, that cord is in the wrong spot, isn't it? All right, so that's better. So that means that if I say each tick mark, each full tick is 5, that means this is 5. That means 1, 2, 3, 4 5s across there, that's 20 inches. 1, 2, 3, 4, 5, 6, 7 times 5, 35 inches. Okay? So that gives you the size of the object. Then you have to figure out what kind of scale you need to get it small enough to draw on the piece of paper. And then you're going to want to note that scale on the drawing in the title block that we've used all along. Okay? So I could say, it's 10 inches. Every full tick mark. Now be careful because this has a half tick mark there, and then a full, and a full. So this is 1, 2, 3.5 ticks. And if I say they're 10 inches, that would be what? 35 inches. Okay? So look at Blackboard, see what the scale is going to be. Then think about your layout on your piece of paper. And you need some room, right, between the views. So we don't want it so small that it looks goofy on the paper, and then we don't want it so big that you can't get any notation around it, right? So a little bit of a game we play, but you're going to put the front view here in this region, right? And then the side, and then the top. So there's the 3 view boxes. And then you have to figure out, like, oh, if this thing is 30 inches here, right? And let's say, I don't know, it's 40 inches tall. So that's 70 inches. And I want some space here and here. So I know this distance is about 8, maybe, right? In 8 real life inches. But I'm going to take away, take away an inch. I'm going to take away 2 inches and just say, okay, I have 6 inches of usable space for these 2 views, right? Because I don't want to use this inch, and I don't want to use this half and this half. Okay, so maybe you get that, hopefully. But I need 70 to go into 6. Like, whoa, how many times do I got to reduce 70 inches to get it down to 6 inches? How many times? Right? Well, let's just see. If I take 70 and divide by 6, that's 11.66. All right? So that's how many times this has to be reduced to get to that. So maybe I'm going to shoot for like 12. So I'll say 70, enter, 12, divide. That gives me 5.8 to fit in the 6 inches. That should work. So maybe I use a scale of 1 to 12. Now, I should check this, if this is 70 inches and this is 30 inches, and I have 11 inches, so maybe I have 10 usable inches of paper space. Then I should check this one too and figure out the scale, see if the 12 works, right? So if it does, then that's my scale. And then to draw, I'm going to have to use my calculator because 12 is not on this thing, right? It's just not on here. There is no 12 scale. It goes up to 6. That means I got to use my calculator. So if I want to draw 30 inches at a 12 scale, I have to take 30 and divide by 12, and I would draw it 2.5 inches. And anytime you use your calculator, you're going to use the 10 scale to read it. Okay? All right, so a little bit of fun with scales. If you've never done this before, this could be a little challenging, so don't hesitate to reach out to me and ask questions, and I can shoot another video that's maybe more focused on one specific thing. Or I can do an example problem. Yeah? All right. Sounds good. I will see you all on Friday. I don't think we're going to have a quiz, but you'll have a homework set for the weekend. And then we're going to build up to having an exam. Maybe not next week, but maybe the beginning of the following week. All right. Take care of yourself, and I'll see you on Friday.